You can see the chapter one, it is nothing but it's something about introduction and environment setup, right? So basically the things what we are going to discuss in chapter one, you might be know from your academics. It is nothing new. These things are already touched to you by your in your academics, right? So what is computer, how computer works, what are the different programming languages, how computer programs exactly work, what are the different types of applications, what are the different ways we can develop applications. So what is algorithm, pseudocode, what is exactly program, what is flowchart, right? Then we will give a bit introduction to C# programming language. Then I will show you the .NET framework architecture and what are the different components available in .NET framework. Then I will show you how to download and install Visual Studio on Windows operating system. And finally, we will create a small application using Visual Studio and C# programming language, and that will conclude our chapter one. So basically, in chapter one, if you look, we are not going to discuss any program, right? So it is basically something like theoretical concepts. It might be boring to you because even I don't like theories in my academics. So, but yes, but I hope once you started these chapters, then you will learn something new. You know all these things, but you will learn something new, right? So so today I'm targeting this past two lessons. That is how exactly the computer works and introduction to programming languages, right? So let's start. Okay. So to understand how exactly the computer works, so my screen is visible to all of you, right?
Yes, yes, we are able to.
Okay. So you can see this is the diagram of a computer, right? So you can see there are many components. One is input, one is memory, one is hard disk, one is output, and one is CPU. So these are the five major components of a computer. Apart from these five components, there are also many other components, but from the high level overview, we can identify these components. This is the input devices, right? Keyboard, mouse pointer is your input devices. So whenever you buy a phone or whenever you buy a laptop, always you are asking what is the RAM size and what is the hard disk, right? External drive. So this main memory is nothing but your RAM, and this is nothing but your hard drives, right? Hard drive. So then there is something called the CPU, and the CPU can having two important components. One is ALU and another is CU. ALU nothing but arithmetic logical unit, and this is control unit. And you have something called output. Output devices like monitor and your printer. These are the output devices, right? Now the most important point that we need to understand is what is the role and the responsibility of each computer, right? Whenever we execute a program or whenever we execute something on our machine, how exactly this is executed by the CPU? Because CPU is the one who is going to process the things, right? So that we need to understand in detail. So let's start with the CPU. So CPU basically it is the central processing unit, or you can say it is the heart of the computer, right? Or you can say it is the brain of the computer, right? All the arithmetical operations, right? All the arithmetical operations or all the logical operations. Arithmetical operation in the sense the addition, subtraction, multiplication, all these things. And the logical operations means greater than, less than, greater than, equals to, less than, equals to, and the logical operation. Logical. If you, in your academics you might be known something about logical and logical nor, right? Logical or logical not. So all these operations are going to be handled by this component called ALU. Then what is ALU? It is actually one of the component inside CPU. CPU contains two components. One is ALU, which is basically to handle or to perform the operations, right? Then another component is CU. CU means it is the control unit, right? So control unit basically what exactly its role and responsibility is. So basically it will make a connection, right? It will establish a connection to the main memory. So so that the CPU can access the main memory, right? So in simple word, we can say that control unit controls the other component of the computer. Other component, like if your CPU needs input components, then the control unit make a connection or make with the input unit or the output devices, main memory, hard disks, right? So the control unit's main job is to manage the other resources. As you can see, the other resources are input devices, main memory, output devices, hard disks. So this control unit manages all these devices, right? So ALU to perform the arithmetic and the logical operations, CU to control all the other devices. How it is going to control all the other devices, that I will show you practically, right? Is that clear? What is the role and responsibility of CPU? Any
Yeah,
doubt?
yeah.
Any doubt regarding CPU? Okay, fine. So then let us discuss the hard disk, right? So hard disk, basically what happens now, whenever you want to store something permanently on your machine, this hard disk comes into picture. Whatever you store in the hard disk, it is a permanent storage, right? So whenever you install any software, then two things are getting installed. Can anybody tell me what are the things? Suppose you install Notepad, then one is program file, another is data file. These two things are going to be installed on your machine, right? If you install MS Office, then MS Office is the program file which is going to be installed. Then whatever the document Excel file you created, those are nothing but your data file. Similarly, if you install Notepad, then notepad.exe is the program file which is installed somewhere in your computer, and whatever the text file you have created, those are nothing but your data files, right? So if you see, let me go to my computer and show you. So in somewhere Windows System 32, you will see somewhere Notepad is installed. You see now? So notepad.exe is installed inside system.windows 32, right? So that means what? Now whenever we install any software, the program file is always going to be installed. Once the program file installed, then we can create all the data files. The data files are nothing but the actual file which is going to store the data, right? Suppose this notepad.exe is installed in my Windows.system32 location, then only I can create the documents, right? So then I can create the text file. This text file is going to store somewhere else, and this text file will be considered as the data file, right? So whenever you install anything on your machine, so two things are going to be installed. One is program file, another is data file. In case of Notepad, notepad.exe is the program file, and whatever text document you created, those are nothing but your data file, right? Similarly, if you take the example of MS Office, so the MS Office application that you install on your machine is going to be your program file, and other documents, right? The Word document, Excel document, Power document, whatever you created using the MS Office package, those are going to be data files, and those data files is going to hold the actual data, right? Is that clear?
Yeah, yeah, yes, clear.
Now the question is, okay, so you can take other examples as well. So music player in your computer, notepad in your computer are program files. Any application or software you installed on your computer is a program file. Movies, songs, Word document, text files, whatever other files that you created using the program files are nothing but your data files. So this data file actual contains the actual data, and on this data file you can perform the different kind of operations. If it is a movies or song, then you can watch, right, using the program file. In that case, what is the program file? It might be Windows player, media player, it might be VLC media player. So VLC media player, Windows media player, these are nothing but your program files. And whatever movies, let's say RR movie, KGM movie, these movies are nothing but your data file, right? So I hope you understand what is program file and data file. Now, the next important component is main memory, right? See, whenever the user wants to run any program, right? When I'm saying program means program files, then that program file should be brought back into the main memory so that the CPU can execute it, right? So this is the main memory. Suppose you want to execute, suppose there is an icon called a Notepad++. Whenever you click on Notepad++, then that program file, that Notepad program file will be brought back into the main memory, right? And then only CPU can access that. Why I'm explaining this concept? Now the reason is while later while we are going to develop Visual Studio applications, then at that time I will show you the memory utilization. So you need to be thoroughly understand how the memory is utilized, right? So that you can develop better applications, because you need to effectively utilize the memory and the CPU resources for better performance, right? That's why I'm explaining this thing. So whenever you want to perform any kind of operations on a program file, and if you want the CPU wants to access that program file, then that program file should be brought back into the main memory. Once the program file brought back into the main memory, then the CPU can access the data. Okay, let me clarify this. Suppose there is a okay, notepad. So suppose this is the notepad icon, you can see, right? So currently, let me open my task. Okay, let me close this one. Okay, let me open task manager. So currently, you can see there is no notepad in the app location, right? Give me a minute. Give me a minute. Okay, so you can see currently there is no notepad application in the apps location, right? So you can see now I'm going to type notepad, and when I click on the notepad, you can see the notepad application is loaded into the main memory. You can see the memory utilization, how much space it is taking in the RAM, right? Once it is loaded into the memory, then CPU can access that. Until unless you have not loaded the program file into the application, you cannot access it, right? Now you can see there is a file called on title notepad, because we have not given any title to this file, and then only CPU can access this. Now whatever operation you can do, you can type, that is fine. But until and unless you have not loaded the program file into the main memory, you cannot access the data, right? And one more thing, if you uninstall notepad application, then this text file what is you saved on your local machine is not going to be deleted, right? If you uninstall notepad, this text file will be there in your machine, but you cannot do anything with that file because the program file is not there. If the program file is not there, then the main memory cannot we cannot load that program file into the main memory. As we cannot load that program file into the main memory, then the CPU cannot access. Is that clear? Hello?
Yes, yes. Yeah, clear.
Okay. So okay, let me give you another example. Suppose, okay, let me close this one. Okay, suppose I am going to develop an application using Visual Studio. You might not know what is Visual Studio. later will show you, but just now consider Visual Studio is an application which is installed in my machine. So Visual Studio is the program file, and using this program file we can create data file. Data file in this case is nothing but the application. Suppose I created one application, right? Okay. Okay. So you can see, so suppose I'm typing something here, console dot write line. Okay. Don't go with the code. I will explain later. Okay. Right. Right. Now, if you look at the things, then the Visual Studio is loaded and its related files. So these are nothing but your services, right? In order to run Visual Studio, there are multiple services required, and all these services are running in the background, right? So this is. But did you see anywhere the application console up to? No, because we have not run this application yet. As soon as I run this application, then you can see that application here, right? Similarly, in Notepad, you can see this is the program file and this is the data file. Similarly, Visual Studio is your program file, and the application that we created here is nothing but your data file, right? So as soon as I run this application, you will see that this application is also loaded into this section. Okay, let's start. Let's run this. Yeah, my application is running, right? Now you can see somewhere, yeah. So you can see console up to this is the data file. And now whatever variables whatever the variables, suppose here I'm creating one variables, right? So whatever variables or whatever variables I'm going to be created, those will be created inside the RAM only, right? So those will be created inside the RAM memory. These are not going to be created on your hard disk, rather it will be created on your RAM, right? So basically you just need to understand, as long as it is not loaded into the RAM, you cannot access it, right? So as this application is loaded into the RAM, the CPU can access it, and the CPU can perform the different kind of operations. Is that clear? Clear or any doubt?
Yes, clear.
Okay, then you might know so there is nothing to explain regarding input devices and output devices, right? So but the most important thing that you need to understand is, suppose you want to provide some input from your keyboard or from your mouse, then those input will be provided into some special location called input buffer, and the main memory cannot access your input or output devices directly, right? Suppose suppose here I'm entering something. I enter any text. I'm entering some value like this, right? Good morning. I'm entering this value, good morning. This good morning value not directly provided into the RAM. It will be stored. It will be stored inside the input buffer, right? And the main memory can access the input buffer only. So whatever input required, main memory will fetch from the input buffer. And whenever you are giving some input, that input will be stored inside the input buffer, right? And same in the case of output devices. If you want to print something, so here you can see, hi, enter any text. We are printing something in the console, right? So that input device main memory not directly printing on the console, rather main memory put that inside the output buffer, and from the output buffer, the output screen fetch that data and display it. Right? So what is the role of input buffer and output buffer? Input buffer is basically going to hold the input data, and this input data is going to be fetched by the main memory. So what is the output buffer? Now, whenever we want to display something on the output screen, the main memory will provide those information to the output buffer, and from the output buffer, the output screen fetches the data, right? So main memory, it is basically, you can say it is the working memory, because whenever we run any application, the data or information is going to be loaded into the main memory. That's why we can also call this memory as working memory or main memory. What is hard disk? Now, whenever we install any software on our computer, then two files are created. One is program files and another is data files. Those files are created inside the hard disks, right? And hard disks, whenever we store anything, those are going to be permanent storage. What is ALU? Now, if we want to perform any arithmetic operations, then those are going to arithmetic or logical operations, then those are going to be performed inside the ALU. And what is U? It is the control unit, and this control unit is basically manage all the other components of the computer, like input, memory, output, and a hard disk. CPU wants to communicate with the memory, this control unit memory wants to get the data from the input buffer, this will manage CU manage this, right? So I hope you understand how exactly the computer works. Is there any query regarding this diagram? Or if you don't understand anything, then you can ask. So shall I proceed for the next concept?
Yes, sir.
Yes.
Okay. So see.
Yes, thank you.
Yeah. So next we are going to learn something number system, and I hope in your academic you already know the number system, right? I'm not going to discuss every number system. I'm going to discuss two important number system. One is binary number system and another is decimal number system, right? Why I'm going to discuss I'm going to discuss these two number system. The reason is, as a human being, we use the decimal number system, but computer use binary number system, right? So binary number system contains only 2 digits. You can see 0 and 1, and the decimal number system contains the digits from 0 to 9, 10 digits. Then the question is, sir, but in decimal number system we are using any uncountable number, and how is that possible? Yes, this is possible because of the combination of this number. Then the same thing is also happened in the case of a binary number system. So in binary, 0 means 0, 1 means 1. Then how to represent binary to how to represent the 3, 4, 5 other numbers? Now this is possible by using the combination of a number system. See, see how we saw the numbers and how computer saw the numbers. These are two different things. We as a human being follow decimal number system. Computer as a machine follow machine code, or you can say binary number system, or you can say 0 and 1. So we need to understand what is binary number system and what is decimal number system. Okay. So suppose for better understanding, please have a look at this table, right? So in decimal we have 0 to 9, and then we have 1 0 1 1. So the combination comes into picture. In binary, this is binary 0 1 2 3 and like this. So if you want to understand how this is possible, let me give you some example. Okay. 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 So this is 0. So 0 0 0 in binary, and it is 0 in decimal. See, right? And 0 0 0 1. So this is nothing but 1 in decimal, right? Now, so if I add 0 and 1, so what will be the output? It is will be like this. So this is nothing but 1, right? Now if I want to add another 1, so this is nothing but 1 in binary and the same in decimal. So 1 plus 1 means what? In decimal it will be 2. Then what will be the value in binary? See, whenever we are adding in decimal, 1 plus 1 equals to 2, but in binary number system 1 plus 1 is going to be 10, right? So in that case 10 means like this. So 1 plus 1, this one and this one will become 10. So 0 will be 1 and 1 will be carry forward. then 1 plus 0, 1, 1 plus 0, 1. So it will become 2. So this is nothing but 2 in decimal number system. So as a human being, we consider it as 2, but for computer, it is 0, 0, 1, 0. Right? Similarly, if we add another 0, another 1, so this is 1, then what will be the value? Can anybody tell me? It will be like 0, 0, 1, 1. Right? Why? Now it will add 1 plus 0 becomes 1. 1 plus 0, it will becomes 1. And like this, right? Again, if I would add 1, then what will happen? Now this is the value of a 3, right? And if I add 1, then it will become what? So
0, 1, 0, 0.
yeah. So 1 plus 1, it will become 0, 10. So 0 will be 1 and carry forward will 1. 1 plus 1 becomes 10. So 10 plus 0 equals to 0. So it will be 0 and carry forward equals to 1. This is nothing but 4 in your decimal number system, right? So this is what you can see in the diagram. So 0, this is 1, this is 2, this is 3, this is 4, right? So this is how we show the numbers, and this is how computer understand the number. Then the question is, so it is a very small number, right? We are doing some arithmetic operations and adding 1, 1, and we can easily identify. But if we have a very big number, then how we can identify or how we can calculate what is the equivalent binary number? So for example, you can see in the screen 29. So you need to understand the binary number system base is 2 because there are only 2 digits. So whatever the decimal number, we need to perform a successive division by 2 to get the binary equivalent of that decimal number, and then we need to read the reminders from bottom to top, right? So suppose you can see in the diagram, so 29, if I do a successive division to the remainder, so it will be division 14, 14 into 2, 28, so remainder will be 1. So same thing, 2 into 7, 14, so remainder will be 0. 2 into 3, 6, remainder will be 1. 2 into 1, 3, remainder will be 1. 2 into 0, remainder will be 1, right? So then we need to read from bottom to top. So from bottom 1, 1, 1, 0, 1. So for decimal 29, the binary equivalent is 11101. Is that clear? Is that clear how you can calculate the binary number of a decimal number?
Yes, yes. Yeah. Understood.
Now suppose we have given one binary number and we have asked to calculate its equivalent decimal number. Then how you can calculate this? Okay. So suppose we have this binary number 10101. I don't know what is its equivalent decimal number, and I want to calculate its equivalent decimal number. Then how we can do this? See, this is the, so we need to calculate based on the indexing position, and the indexing is going to be start from 0, right? So this is the most recent bit. So 1 into 2 to the power 0. This is 0, 0 into 2 to the power 1. This is the second, so indexing 0 means this is 0, this is 1, this is 2, this is 3, this is 4. So this is the second index. So 1 into 2 to the power 2. This is the third, 0 into 2 to the power 3. This is the fourth one, 1 into 2 to the power 4. And then we need to calculate. So 2 to the power 0 equals to 1, 1 into 1 equals to 1. So whatever you multiply with 0, it will become 0. So 2 to the power 2, 4 into 1, 4. 0, you are multiplying with 0 means it will become 0. 2 to the power 4 equals to 16 into 1, 16. If you add this, this is 21. So for this binary number, the equivalent decimal number is 21. Clear or not?
Yes, clear.
Okay. Okay. So this is nothing but how computer exactly work. So computer, we have basically some components, right? So let's summarize what we discussed. So the computer can have mainly 5 major components: input, output, main memory, CPU, and hard disks. And we discussed there is something called input buffer and there is something called output buffer. And we also discussed that if you want to perform any kind of operation, read-write operation or mathematical operations, then the program file needs to be brought back into the main memory. And once the program file brought back into the main memory, then CPU can access them, right? So we have discussed this, and then we discuss what is number system, right? As a human being, what number system we follow. As a computer follows the binary number system that we discussed. And we also discussed how to convert a decimal number system to binary number system, and how to convert a binary number system to decimal number system. I'm not going to touch this concept because these are not required for us to understand, because computer is going to work on binary number system that we need to understand. Human being, we are going to use this number system in our application, so we need to understand this. So these two I have discussed, and then we discuss how to convert decimal number to binary number and how to convert binary number to decimal number system, right? And guys, one more thing. So while I'm explaining, don't try to write anything, right? Because I'm going to provide these documents to you only. So while I'm explaining, don't write anything on your own, right? Because if I'm explaining and if you are writing, then you are not a software engineer. You are a typewriter. The job of a typewriter is to type writing. And if you are doing the same thing, then you are not a software engineer, right? So definitely I will provide these documents to you guys, right? So yeah.